Hello students, in this video we'll discuss how you find critical values of functions of several variables and see an example. Given a function, we'll focus on two variables for the time being. Z is equal to f of x, y. We say that a point AB is a critical point of f if the gradient of f at the point AB is the zero vector, which is, of course, for a function of two variables, is equivalent to saying that the x partial derivative at AB is equal to 0, and also simultaneously the y partial derivative at AB is equal to 0. And so that's what a critical point is. And then we'll say, so here's the second derivative test. Second derivative test. Second derivative test says a critical point AB is a local min if lambda 1 and lambda 2 are greater than 0, a local max if lambda 1 and lambda 2 are less than 0, and a saddle if one of them, say lambda 1 is positive and lambda 2 is negative. And of course, here the lambda 1 and lambda 2 are the eigenvalues of the Hessian matrix. So lambda 1 and lambda 2 are the eigenvalues of the Hessian matrix, Hessian, which is Hessian matrix, which will be at AB, which is fxx at AB, fxy at AB, fyx at AB, fyy at AB. So that's our Hessian matrix. So let's see an example of how we classify local max, local min, or saddle. So here's an example. Let's find and classify the critical points of the function f of x, y is x squared plus y minus 1 squared. So there's our function. So let's compute the gradient of this function. The gradient of this function is 2x plus 2y minus 1. So there's a comma there. So 2x for the x partial derivative, and the y partial derivative is 2y minus 1. And if we set this gradient to be the zero vector, we see the only way that's going to happen is if x is equal to 0 and y is equal to 1. So the only critical point here is the critical point 0, 1. Now let's compute the Hessian matrix. So what's the Hessian matrix going to be? So the Hessian matrix of f at the point AB is going to be, well, fxx is just going to be a 2, fxy is going to be a 0, and fyx is going to be 0, and then fyy is going to also be a 2. So over here we see that we have a diagonal matrix, and we know that the eigenvalues of a diagonal matrix are just the diagonal entries. So lambda 1 is equal to 2, and lambda 2 is equal to 2. So I have two positive eigenvalues, and that tells me that the point 0, 1 is a local minimum. Thank you very much.